Hello all, welcome to Scientifax. In this video, we'll be discussing about the motion of the objects under the influence of the gravitational force of the Earth. Let us take an example. Take a feather and a hammer. Now drop them simultaneously from the same height. What do you observe? We can observe that the feather reaches the ground a little later than the hammer. This happens because of air resistance. The air offers air resistance due to friction to the motion of the falling objects. So basically there is a friction between the object and the air which slows down the lighter object more than the heavier object. So therefore the lighter object falls much lower than the heavier object. What happens to the same objects in a vacuum? We know that vacuum means that there are no air molecules present. It's basically empty space. So therefore when we drop the hammer and the feather from the same height, both of them strike the ground at the same time. There is no air resistance to stop the lighter object. Air resistance does stop the heavier object, but there's no air resistance to stop the lighter object because there's like a more major impact on the lighter object. It falls much slower. In air, if you see that because of the air resistance which is more in the lighter object, it falls much lower, whereas the hammer has already struck the ground. In a vacuum, there's nothing called air resistance over there. So therefore, both of them strike the ground at the same time. How do all the objects fall at the same rate? We all know that an object experiences acceleration due to free fall. We've already seen this in a previous video, seeing acceleration due to gravity. That is only acceleration due to free fall. This acceleration experienced by an object is independent of its mass. So whether the body is 20 kgs or even 200 kgs, it will be the same acceleration, which is 9.8 meter per second square. So the acceleration experienced by an object is independent of its mass and depends only on the gravitational force of the Earth. So it depends only on the force of gravity which is exerted by the Earth on all the objects. Since the force of gravity exerted by Earth is the same on all objects, which is 9.8 meter per second square, they fall to the Earth at the same time irrespective of their masses and size. Note: as g is constant near the Earth, all the equations for the uniform accelerated motion of objects become valid with acceleration replaced by small g. Also, distance or displacement, which is denoted by small s or s, will become h, which denotes height. So basically, what they are saying in this paragraph is acceleration due to gravity near the Earth is constant. All the equations for the uniform accelerated motion will be replaced by g, which was acceleration is actually a, but in this chapter, as it's acceleration due to gravity, it becomes g. Also, distance or displacement. So in the previous chapters, s denoted distance or displacement, but over here it denotes height, which is denoted by h. So therefore, first equation was v equal to u plus at, but since a gets replaced, it's v equal to u plus gt. Second equation is s is equal to ut plus half at square. Since s is replaced by h and a is replaced by g, it becomes h is equal to ut plus half gt square. Third equation, v square equal to u square plus 2gh. So here, a is replaced by g and s is replaced by h. So therefore it becomes v square equal to u square plus 2gh. Note: the acceleration due to gravity, which is denoted by small g, will be positive when it is in the direction of the velocity. It will be negative when it opposes the motion. Let us take an example. The car falls off a ledge and drops to the ground in 0.5 seconds. Let g be 10 meter per second square. what is its speed on striking the ground? So we need to write what is given. A car falls off a ledge. So basically it was stationary before it fell. So therefore the initial velocity, which is denoted by u, is equal to 0 meter per second. And the time as they have given is 0.5 seconds. G is equal to 10 meter per second square. Actually, small g is equal to 9.8 meter per second square, but for calculation purpose, it is converted into 10 meter per second. It's rounded off to 10 meter per second square. So here, speed v equal to u plus gt. So speed over here is denoted by final velocity. Here, speed, they are referring to final velocity. So as we saw, first equation v equal to u plus gt. So therefore, we need v equal to u plus gt. So u is 0 meter per second square plus 10 meter per second square into 5 seconds. That's 50 meter per second. Meter per second is the SI unit of velocity. What is its average speed during 0.5 seconds? We all know that average speed is basically like we have to add the quantities and divide it by the number of quantities. So therefore, u plus v by 2. So initial velocity plus final velocity by 2. So initial velocity will become 0 meter per second as they have given. Final velocity is 50 meter per second as we found it out over here. 50 meter per second as we found it out by 2. So therefore that's 25 meter per second. How high is the ledge from the ground? We need to find the height. Height, which is denoted by h, is equal to ut plus half gt square. As we saw the second equation. H is equal to ut plus half gt square. U into t. So therefore it's 0 into 5 seconds, which is equal to 0. Anything multiplied by 0, 0. Plus half into 10 meter per second square into 0.5 second square. We need to multiply half into g into t square. So when we do half into 10 meter per second square into 0.5 second square, we get 1.25 meters. Example 2. An object is thrown vertically upwards and rises to a height of 10 meters. Calculate the velocity with which the object is thrown upwards. So we need to calculate the initial velocity. Whenever they say an object is thrown vertically upwards and rises to a height of 10 meters, rises to a height of 10 meters, it means that the final it stops for a second over there, not exactly a second. It stops for a fraction of a second in the thing, in that height. So therefore, the final velocity will become 0. And as they are given, height is equal to 10 meters. Acceleration due to gravity, which is denoted by small g, is equal to minus 9.8 meter per second square as it acts against the motion of an object. So gravity acts towards the earth. So therefore, when we throw something upwards, it acts against the motion of gravity. So therefore, it will be minus 9.8 meter per second square. We even saw here. G will be positive when it is in the direction of the velocity, direction of the force of gravity in this situation, and will be negative when it opposes the motion of gravity. So here it is opposing the motion of gravity and hence it will be negative. So we can use the third equation, which is v square equal to u square plus 2gh over here. V square equal to u square plus 2gh. So therefore now v square, when we transpose this terms, will become v square minus u square equal to 2gh. This will go to the left hand side and only the remaining will be 2gh in the right hand side. So v square minus u square equal to 2gh. So then we get minus u square equal to 2 into minus 9.8 meter per second square into 10 meters. So therefore, we will get it as minus u square equal to square root of minus 196. But we can make it as u square square equal to root of 196. So if we just make the left hand side plus, we can make the right hand side plus as well. So u square equal to root of 196, which will be u equal to 14 meter per second. That was the initial velocity is 14 meter per second. That was the velocity with which the object was thrown upwards. The time, we need to calculate the time taken by the object to reach the highest point. Now you can use the first equation again, since it includes the time and we have found out the final velocity and initial velocity. So 0 meter per second, which is the final velocity, equal to 14 meter per second plus minus 10.8 meter per second square into time. So when we transpose these things, we can get t equal to 14 meter per second divided by 9.8 meter per second square. So therefore, when we divide this, we get the time as 1.43 seconds. So the time taken by the object to reach the highest point will be 1.43 seconds. Hence, we conclude the session with this. Please don't forget to like, share and subscribe. We'll meet in next time. Thank you once again.